Welcome to This Explainer. Have you ever wondered how massive digital platforms are constantly updating their code, rolling out brand new features and squashing bugs, all without ever going offline? I mean, gone are the days of developers sweating over their keyboards at 3 a.m., literally praying the servers don't crash during an update. Today, we're going to demystify exactly how that automated magic works. We're diving deep into how CI/CD pipelines function, which is the exact technology allowing developers to seamlessly push code from their laptops straight to millions of users all around the globe.
All right, let's set the stage by appreciating just how ridiculously complex modern applications actually are. Think about uploading and transcoding a video on a platform like YouTube. Behind the scenes, that architecture is massive. We're talking load balancers, API servers, metadata databases, and worker queues all firing and communicating in real time. When a system gets that big, you absolutely cannot just drag and drop files via FTP onto a server to update it anymore. One wrong move and the whole system comes crashing down.
It's exactly like Alex Yu points out in his book, System Design Interview. Manual updates in systems of this scale are just a recipe for absolute disaster. Relying on humans to manually copy files or meticulously configure servers for every single update, it's way too slow, it's way too prone to human error, and ultimately, it just doesn't scale. In this world, automation isn't just some nice-to-have luxury, it is an absolute necessity.
So here's our blueprint for today's digital assembly line. We'll start with 1. Taming complex system architectures. Then 2. Enter the CI/CD pipeline. 3. Phase 1. Continuous integration. 4. Phase 2. Continuous deployment. 5. The magic of zero downtime. And finally, 6. The future of automation.
Let's kick things off with Section 1, Taming Complex System Architectures.
To actually manage this wild complexity, massive operations have to be broken down into what's known as a directed acyclic graph, or a DAG for short. You can think of a DAG as a super strict, highly parallel digital flowchart. For instance, a preprocessor sends data to a scheduler, which then orchestrates resource managers and task workers. Now, here's the catch. Updating even a single tiny piece of this workflow requires surgical precision. If a developer updates the code for a task worker, it has to be deployed so perfectly that it doesn't break its existing connections with temporary storage or the resource manager. It's like a giant puzzle where every piece has to fit flawlessly while it's moving.
Which brings us right to Section 2, Enter the CI/CD pipeline.
So the million-dollar question. How do we achieve that flawless precision safely and consistently every single time? Well, the first half of that magic trick is continuous integration, or CI. This is the practice where developers are frequently committing their code to a central, shared repository. But here's the kicker. It's not just a dumb storage space. The exact moment that code is committed, it automatically triggers a robust build and testing process. CI ensures that every single new line of code is instantly verified through automation. It detects bugs early, way before they ever get anywhere near your users.
And then we have the second half, continuous deployment, or CD. Now, CD picks up exactly where CI leaves off. Once your code is fully integrated, rigorously tested, and packaged up into what we in the industry call an artifact, the CD pipeline takes over. It automatically moves that validated code across various environments, like testing, then staging, and ultimately pushes it out to production, directly to the end user.
All right, let's break this down further in Section 3, Phase 1, Continuous Integration.
Let's follow a single piece of code on its journey. Our story begins locally, right on a developer's laptop. They write their code, they test it out locally, and then they use standard version control commands, usually Git. They stage their changes with a Git add, commit them to their local repository with a Git commit, and finally, they blast that code off to a central cloud repository like Azure repos using Git push. And right there, that push, that is where the automation entirely takes over. The moment that git push command executes, it acts as a continuous integration trigger. This central repository sees the fresh code hit the master branch and automatically spins up a pipeline agent. You can think of this agent as a dedicated Microsoft-hosted virtual machine that literally springs to life in the cloud for the sole purpose of processing this new code.
Once this agent is awake, it works at absolute lightning speed, running through a very strict checklist. First, it fetches the fresh source code. Then, it restores any required third-party libraries so all dependencies are met. Next, it builds the entire solution from scratch using a highly optimized release configuration. Then it runs a barrage of automated unit tests to ensure nothing was broken by the update. And finally, if it passes all of that, it publishes the final packaged output into an artifact. This is often just a neatly bundled zip file containing literally everything the application needs to run.
Now we're ready for Section 4. Phase 2. Continuous deployment.
So, we have our packaged artifact, the hero of our story, and we know the code works. But how do we get it to the users without causing a meltdown? In this phase, the artifact progresses through a very strict gauntlet of environments to totally eliminate risk. It doesn't just YOLO its way to the live site. First, it's published to a dev box for initial sanity testing. Then, it moves to a QA box, where quality assurance teams can poke and prod at it. Next, it hits staging, which is basically an exact replica of the live environment. And only then, if it survives all that, does it finally make it to production.
Now, you might be thinking, this sounds a bit too automatic. But even though it's an automated pipeline, it doesn't mean we just let it run wild. We can easily insert manual intervention gates. For example, the automated pipeline can push the code to the QA environment and then just pause. It will literally sit there and wait for a human QA manager to log in, verify the new features, and physically click approve before the automation kicks back in to move the code to staging in production. It really is the perfect blend of machine speed and human oversight.
Which brings us to the coolest part of the whole process. Section 5, the magic of zero downtime.
So how exactly does this code enter production without interrupting a user who is literally right in the middle of clicking around the app? Well, let's compare the old way to the CI/CD way. The old way meant publishing directly to the live server. You were literally overwriting files while people were actively trying to use them. The result? Complete server downtime and those nasty status code 500 error pages for your extremely frustrated users. But with CI/CD deployment slots, it's completely different. We publish the new artifact to a completely hidden staging slot right on the production server. We let the new application warm up in memory in the background, and then we just swap it seamlessly with the live production slot.
This trick right here is exactly why you basically never see those retro animated site under construction GIFs on the internet anymore. Because of this seamless swap, user requests that are currently executing on the old code continue totally unaffected. Meanwhile, any new user request that comes in just a millisecond later instantly hits the newly updated code. The whole swap happens flawlessly, behind the scenes, and the end user has absolutely no idea it even happened.
Finally, let's wrap things up with Section 6, the future of automation. Stepping back for a second, what does building this incredibly precise digital assembly line actually accomplish for modern software teams? By entirely removing those manual, anxiety-inducing drag-and-drop file transfers, teams unlock some massive benefits. You get smooth, error-free deployments. Because the pipeline pushes the exact same artifact to QA as it does to production, there is zero chance of an environment configuration mismatch. You also get a complete automatic log history of exactly who deployed what and when. But above all, you vastly improve developer productivity. You're freeing them up from tedious server maintenance so they can focus on what they actually do best, writing great code.
Ultimately, the CI/CD pipeline takes software development from being the stressful, incredibly risky chore and transforms it into a reliable, instantly repeatable process. Now that you understand how these vital automated arteries of modern software function, it's pretty clear that infrastructure is no longer the bottleneck. The pipeline is built, the tests are fully automated, the deployment is instant. So the only question left for you is, what are you going to build next?